Intuit, and Katie was nominated to do the closing keynote way before I got to Intuit. So I don't want anyone thinking that I somehow influenced this agenda. Part of the reason I joined Intuit, as I said earlier, is because of the amazing work in open source, in Argo, in all, many things that I'm extremely passionate about, and communities that I already play in CNCF. And as a CNCF ambassador, I knew a lot of the team. But it's amazing to be here. I've only been here for like literally a few weeks. So I haven't met a lot of the team yet. But this was a keynote that we had talked about well into the, earlier in the summer before this was even an idea. So with that having said, not that you needed your own credentials, to be validated, but I just wanted to make that point that because we've had a lot of amazing people from different companies and a lot of amazing people here today, including Katie, who is going to walk us through our closing keynote. Very excited.
All right, we'll duck out now. Over to you.
Awesome. Thank you. Let me share my screen. We can get this going. Great. So thank you so much, everybody, for joining. I know we're running a little bit late, but I'm hoping this is an exciting topic to stick around for. I'm going to be talking about GenAI's role in how we improved debugging build failures. So as Lisa and Danielle said, my name is Katie Lamkin-Fulsher. I'm a staff product manager of platform and open source at Intuit. I have an engineering background, so these are problems that are near and dear to my heart, and a couple years ago moved into the product role. So our agenda, we are going to touch on a little bit of the Intuit developer platform and take a step down into the Intuit build platform and learn a little bit about what our platform looks like, how it functions at scale, and then dive into different development personas and challenges they experience today on our build platform, what our goal is in terms of solving those challenges, how we solved those challenges and how we look to meet our goal, what our hypotheses were for actually achieving those goals. I'll have a couple quick demos that I recorded and then talk about what's next based off what we have built today. So Intuit's development platform, if you heard some previous talks from another Intuit team that works on our IKS platform, you know that Intuit scales tremendously. We focus on scale and robustness, not only for providing a beneficial experience to our customers on the outside with QuickBooks, TurboTax, Credit Karma, but also as a part of the development experience team. My team looks to provide just as positive an experience for our internal users, which are our own application developers themselves. So within the development experience organization, we focus on providing platforms that allow teams to develop and hopefully increase their productivity. Since 2019, as you can see, we have had a 9x increase in developer productivity, and that's huge. That goal is also not something we're just satisfied with then. We want to continue to improve in that space and continue to provide the best development experience for our developers so that they can provide the best experience for our external customers as well. Taking a step down, let's look in particular at our Intuit build platform. So the scale at which our Intuit build platform functions is huge. We have over 200 plus Jenkins controllers, which has 3,200 plus CPUs that power those controllers. And we have over 100,000 builds per day. Those builds are being run by the 2,300 PRs that are open per day by our 1K plus development teams. So as you can see, supporting the amount of development that takes place at Intuit is huge for our build platform. And our build platform doesn't just execute building of artifacts. Our entire CI/CD pipeline executes on our build platform. So for all of our assets, those CI/CD pipelines are functioning there. And it's extremely important that our developers have a positive experience on this build platform because they spend a decent amount of time there. So let's take a look at some of the challenges that they're experiencing today with our build platform. And we've kind of identified a theme here. So for application developers that have had a decent amount of tenure here at Intuit, when their build fails, they've noticed that there are thousands of lines of logs within the build that make it difficult to read through and actually identify, why did my build fail? If you're a new developer, that's joining Intuit, and you're faced with those thousands of lines of logs, that can be even more daunting. As an existing developer that's been at a company for a little bit, if you've been at a company for 1, 2, 3 years on the same team, working with the same assets, you can gather some subject matter expert knowledge about those assets, and it's going to be easier for you to understand what type of failures are actually taking place within your builds. But if I'm a brand new developer that's brand new either to this new team, this new asset, or to Intuit altogether, understanding what those thousands of log lines mean when my build fails can be extremely daunting. And oftentimes those developers have to go reach out to their other team members to help learn from their subject matter experts and help build their own. Not only does that take some extra time, but it also causes other team members to be distracted from the tasks that they're working on in order to help out other team members, which is something we want to do. We want to support our team members. We want to support healthy collaboration, and we want to support information being, learned and educated across all of our teams. But we want to make sure that it's done effectively and not affecting everyone's productivity. And lastly, our platform engineers that are maintaining our build platform find themselves in a position where they're constantly responding to support requests related to build failures. 60% of the support requests that they receive are related to build failures. Out of the 100,000 plus builds that happen per day, our success rate is 75%. So that means that 25,000 plus builds that fail per day are builds that developers may need assistance on. And if they need assistance on it, they reach out to our support Slack channel, and a platform engineer will try and help them as best they can. But you can imagine that if per every build or per every developer that ran into a failed build reaches out to the support requests, that can get pretty daunting for our platform engineers to experience. So all these challenges relate to one another just a little bit differently for each individual persona. And so we knew that this was something that was going to be worthwhile for us to try and attack. Now, let's take a look at our developer lifecycle and see exactly where application developers can run into these build failures. And there's a few different places. So if we take a look at the inner loop, the first step in the inner loop that developers can run into these problems with is obviously the build step. When you're building artifacts, when you're integrating your build with GitHub, making sure that the source code gets pulled down correctly. Maybe you're running your unit tests with Maven or Gradle. We execute code within a cloud workspace using Coder. And so all of these different steps that are taking place during that build process has unfortunately the opportunity to introduce a build type failure. And with the more tools that we use as we continue to get more sophisticated with this strategy, unfortunately, the added complexity gets introduced with that as well. We then have the test step, which also takes place within the inner loop. And we have thousands of automated tests that run on our build platform as well. They can range from unit tests, integration tests, functional tests. And these tests can either take place within the build step, or they can take place within a CI/CD pipeline, or even a cron job that runs nightly. And so as these tests execute, there's a couple different opportunities for failures to be introduced here as well. Failures can be within the actual tests failing to pass, or if the actual frameworks that these tests are executing with have issues, maybe the dependencies aren't there correctly, then the test may not even execute altogether. And so understanding those different types of failures are different scenarios that developers can run into when they're testing their code on the build platform as well. And finally, at the end of the outer loop, we have our release and deploy cycle. Since our CI/CD pipelines are executing on our build platform, that means that for every release and for every deploy, those are also unfortunately opportunities for failures as well within those types of builds and jobs that run on the platform. And we integrate with other deploy tools like Argo CD to deploy out to Kubernetes. And unfortunately, those integrations can be quite complex and have room for failures as well. So multiple different parts of the developer lifecycle, starting from the beginning of the story all the way to releasing and maybe even rolling back of an accidental change, can have failed builds. So what's our goal? This all sounds daunting. It all sounds kind of a lot. So our goal is to improve productivity by streamlining this debugging process. If we decrease manual toil, reduce time to merge, and provide automatic build failure insights, we believe that we can provide a better experience for developers and at the same time remove the dependency of subject matter expert knowledge in teams and allow developers to be able to start building that in a more self-sufficient way and rely less on their team members. So that's our hypothesis. Let's see how we went about trying to accomplish this. So what is our solution? What did we build? How did we solve this problem? So we discovered there was a few different entrance points that developers most commonly use in order to reach out, ask for help, learn more information about their builds. The main entrance point that we focused on first was the GitHub PR. Per every story, per every change the developer is going to work on that relates to a GitHub repository, they're going to create a branch, commit their changes to that branch, and open up a PR. It's their normal life cycle that they're working within GitHub. The system that we have set up today is when a PR gets created, every commit from that PR triggers a build on our build platform. So you can see that we have the Jenkins build notifier, which comes out of the box within Jenkins. So every time a build runs, that Jenkins build notifier notifies our custom build IBP Gen AI plugin and says, hey, there's a build that's running. Let's keep an eye on it. If that build passes, then there's nothing for us to do. There's no failure to analyze. We can move on. If that build fails, the plugin will then traverse through the logs and identify the logs that are associated with that failure. It will then build a prompt and pass the prompt plus those error logs to our Gen AI platform that hosts our LLM models. That LLM model will take the prompt, take the logs, produce a response, and return it back to the plugin. The plugin will then scrub it, make it look a little bit more presentable, and write that response out to the GitHub PR as a comment. So the benefit of this flow is that developers get to stay within the GitHub PR, which is their home base. When you're working within GitHub, when you're working within a PR, that's kind of where you get most of your feedback from, especially during the review process anyway. So the fact that we can take that information and write it directly as a PR comment keeps them kind of in that home base and allows them to stay there without losing context and traversing back and forth between other tools. The second way that a developer can gain access to this information is through the Jenkins UI itself. So, for example, if I'm performing a release or if I'm performing a deploy and I'm going through my CI/CD pipeline, or let's say I have a cron job that runs a series of nightly integration tests, and I notice that a job or step in either of those pipelines has failed. I can go into Jenkins and go to the UI extension related to that build or that job that had failed and traverse to where the summary is, and I'll be able to see the summary and the debugging steps that were provided based off of those failures. So very clean, straightforward. If people continue to like using Jenkins or like using Blue Ocean and they want to remain within that one tool, they can have that experience within that tool as well. And it works very similar to how the GitHub PR is with hooking into the build notifier. The plugin will reach out to the LLM, provide that same information with the prompt and the error logs, and then we just display the response within the Jenkins UI itself. The third and final way we have today to gain access to this information is via Slackbot. So for those that reach out to our support channel and request help on a failed build, we have a Slackbot that's, again, integrated with our plugin that says, hey, I've noticed this developer needs help. They requested help. They passed this build URL in with a failed build. It will reach out to the plugin. The plugin will perform the same computation of engineering the prompt, passing the prompt to the LLM. This will then get returned back to the Slackbot, and the Slackbot will respond in thread in Slack with the summary and debugging steps that the developers need in order to interact with it. The developer can then decide, hey, do I need to escalate to a human engineer, or is this information enough? Did this actually provide me with the information that I need in order to move on successfully with fixing my build? they can also say it is sufficient, and it will automatically close out that support request. So let's see some of these examples live. Actually, first, before we get to our live demos, let's talk about a couple of challenges that we ran into with implementation. So the first challenge that I think is very common when using Gen AI models is prompt engineering. As we talked about earlier, with our inner loop and our outer loop with our development lifecycle, there are many different ways and many different steps in which a build or job on our build platform could fail. We wanted to make sure that our prompt was generic enough so that we could cover 80 to 90% of these use cases, but we didn't want it to be too generic to where it wasn't actually going to provide valuable information for a developer to use it and actually, resolve their debugging steps. So taking the time to figure out a prompt that was going to be best for our first iteration, that it was going to meet that 80 to 90% of requests, was definitely a challenge. How did we approach that challenge? How did we solve for that? Unfortunately, it was trial and error. There's a lot of documentation by OpenAI and that a lot of other research in the open source community that has done based on prompt engineering. And so based off of that research and based off of trial and error, we were able to figure out a prompt that works best for us and gets us the highest accuracy that we see today. The second challenge that I'm going to talk about today, not limited to these two challenges, and these are just the two challenges that I think that are most important to touch on, is model version management. So as Gen AI technology continues to evolve very, very rapidly, new versions of models are being released, new versions of technology are constantly being pushed out, and we want to make sure that we are taking advantage of the latest and greatest, the highest performant, highest quality. But just because a new version comes out doesn't mean it does produce the highest quality of results for us. So having regression testing in place to make sure that, hey, this is our baseline that we have right now with model XYZ. We receive this level of accuracy and this level of quality with our responses. This is our baseline. So whenever we increase a model version, we are able to run our regression tests and compare those tests to previous models and ensure that when we are upgrading our model, we are upgrading to something that is more performant and either of equally of quality or has increased the quality of the responses that we're giving back. We want to make sure that we're not digressing in any way. It's very easy for people to lose trust in generative AI responses when they're not replying back with responses that are either of value or could be incorrect. So ensuring quality was something that we wanted to make sure that was something that was stable no matter the model version that we were on. All right, and now I'll jump to a small demo of what it looks like to have a GitHub PR in place. So you'll see we created a PR. And we had some changes in there, and we're doing this within the scope of the GitHub UI. For the purposes of the demo, normally this would take place on your local machine. You make some changes, you push it up with the terminal. But just for this demo, we are doing it within the UI. So we made some changes, and we are creating a new branch and opening a new pull request. So now that we are opening this new pull request, the pull request is going to trigger a build job on our build platform. Once that build job has executed on our build platform, we will see whether it has passed or failed. And unfortunately, you can see here that under checks and by the comment that was posted in this PR that our build had failed. The PR comment was generated by our Jenkins plugin, and you can see that there was a shell error. It talks about in a very concise and summarized way, here's exactly why this failed. It gives you some probable causes and allows you to go and to determine, okay, what change did I make that I introduced that could have caused this failure? How can I go fix this issue? You can also provide a thumbs up, thumbs down comment in GitHub that provides feedback to the platform team, whether or not this was a good response and helped to actually, solve the issues that were currently being experienced within this build. So let's say I wanted a little bit more information. I want to go directly within the Jenkins UI. I can click my check. I can understand like, okay, here's the step that failed within my CI/CD pipeline. I can go into the Jenkins UI, into the UI extension that we built, and look further into the analysis, into probable causes, and actually go deeper into either the Jenkins logs or the Blue Ocean's logs to understand exactly why this failure occurred. All right, let's move to the next demo, in which we will walk through the Slack example. So this is going to be an example where I am a developer and I want to go into Slack and request support for a build that I'm unsure how it failed. And so I go to my IBP community Slack channel. I write a message that says, hey, my build is facing some issues. Can you help me debug it? So once this message goes into the channel, our Slack bot will start a thread based off of that message. So you can see our Slack bot responded and said, hey, can you help me out by providing the failed build link? So we pass them the failed build link. It's now reaching out to our plugin, gathering the proper information, making sure that we can get the response back from the LLM. And then once we get that response back from the LLM, it's going to write it directly in Slack. We can see that the same information that was posted on our GitHub PR is also posted here. We can state whether or not that does the information that's being provided here actually help us solve a problem, or do we need to talk to a human for further assistance? In this case, we got the information that we need. We know exactly how to fix our problem. We can tell the AI that, hey, we do not need any further assistance. We're good to go. And the AI Slack bot will mark this support case as completed. And you'll see that by the green check mark. And so now as a platform engineer, when you're going through the Slack channel and when you're determining which Slacks do I need to respond to, you'll be able to look at this and say, hey, this has already been resolved. AI took care of it for me, and I can continue on. So what are some initial results that we ran by having these features go live? And did we actually help, right? That's the one big thing. We want to make sure that we're actually improving the lives of developers, application developers, and our platform engineers. So we targeted 1,000+ developers across Intuit, and the accuracy of our analysis was 91%. So it exceeded our expectations, and we were super excited about that. In terms of time saved, we looked at our two different categories of developers, a developer with a tenure of greater than 1 year and a developer with a tenure of less than 1 year. So developers with a tenure of greater than 1 year, we saved 10.1 minutes per build. That's a 59% improvement compared to previously triaging what it took to identify why a build had failed. That's a great improvement. If you can imagine as a developer, you're iterating on a PR and you come across, possibly multiple failed builds within the scope of one PR, shaving down 10 minutes per build failure is something that can really help with not only your own productivity, but the velocity of that PR. And then if we take a look at our time savings for a developer tenure of less than a year, it's a 1.5 hours of improvement. That's a 75% improvement. That's huge. You can imagine, again, being a new developer, taking a look at those thousands of log lines and being overwhelmed, but also trying to put the effort in and see if you can figure it out yourself without distracting your team members. But this tool saved developers hours of time. And not only an individual developer, but that developer didn't have to reach out to their other team members for help as well. They were able to be self-sufficient and figure it out themselves. And so consequentially, we're able to save the time of other developers on the other team as well. That's not calculated here, but it's something that we definitely want to continue and help increase, the confidence of, new developers as they join into it. Here's some quote for our developers, right? Our application developers and, new and tenured are super excited about this feature. It's been called a lifesaver. Having the ability to not sift through those logs and feel more confident when they're facing those build failures is huge. And our platform engineers are super stoked. They love going to support requests and seeing that it's already been resolved for them. Direct quote, you can't beat it, right? That's huge. So what's next? What are the further enhancements that we want to make to these features that we believe will continue to enhance developer productivity and continue to streamline the debugging experience? Well, first, we want to add asset-specific context into the summary. Today, the summary is based off of open source information that's out there. When you have these types of frameworks and when you have these technologies that exist and have documentation available, the models are being trained off of that information, which is extremely helpful for many of our problems. But as a lot of companies will experience, when you've been working with an asset for so long, or when a company does things specific ways, that can also have an effect on whether or not your build passes or fails. And it would be really helpful to have that extra context included within the summary of the build failure, possibly including documentation links that are specific to that asset, that are specific to that repo, or maybe specific to the tool that is causing the build to fail, excuse me. So that's next. Then upcoming in the future, we want to be able to customize the prompts. We want to be able to have people interact with the AI a little bit more than they can today. The interaction today is limited to in Slack, but we want them to be able to say, hey, I went and executed these debugging steps and I found XYZ information. With this information, is there any more guidance that you could provide me to help me gain remediation steps to cause these failures? And so continue to guide and to continue to provide assistance for developers when solving these build failures, as well as we want to have an understanding of, are there trends with these types of failures as well? Is it a particular test that continues to fail? Is it a particular static code scan that starts to fail? Is it an asset that's just flaky and it happens a certain time of day? Can we identify trends in these failures and then create some tech debt items that the team can start slashing and maybe improve their failure rate on their builds altogether? And finally, we want to support local builds so that developers can execute this locally on their machine and they can avoid constantly having to push to our build platform in order to take advantage of this functionality. Open source is also extremely important to us. And so in the near future, we also want to make sure this plugin is available for the open source community to use within Jenkins. And we're also looking at making it available for how can we generalize this so that we can use it across different build tools as well. We believe in open source collaboration across Intuit. Intuit is huge in the open source community. You may know us for, the really popular Argo Proj or our up and coming project Numa Proj. We create open source and maintain many different tools, and we're also an end user of cloud native technology and mobile open source technology as well. If you want to keep up with everything Intuit is doing in the open source community, I highly recommend it. We do a lot of fun stuff. Please look at the bit.ly link for bit.ly Intuit-OSS. And if anybody is going to be at KubeCon coming up, I would love to see you guys there. So please reach out to me over CNCF Slack.